us to another episode on SUG12 exams. So in this episode we are looking at the 2019 Science Paper 1, which is basically physics. So let us look at section A, which has 20 questions, and these are multiple choice questions, and this section carries 20 marks out of 85 marks. Let us look at question 1. Which of the following instruments would be used to accurately measure the inside diameter of a bottle neck? So we have A, the ruler; B, the vernier caliper; C, engineer's caliper; D, micrometer screw gauge. So the best instrument that is used to accurately measure the inside diameter. So the inside diameter is basically the vernier caliper. Remember, the micrometer screw gauge and the vernier calipers are all used to measure diameter, but they all used for external. But the vernier caliper is able to measure the internal diameter. Let us move to A2. The diagram below shows a bulb of a simple pendulum that swings from position A to B. If it takes the bulb 0.5 seconds to swing from A to B, what is the period of the pendulum? So the first thing that we need to understand is what is the period of a pendulum. So the period of the pendulum is basically the total times the pendulum takes to make a complete oscillation. So oscillation is basically, what is it? So oscillation is basically one complete oscillation is a movement from A to B, then B to C in this diagram, then C to B, then back to A. So from B to A. So from A, B, C, then C, B, A is a complete oscillation. So if from A to B, which is just 1/4, is 0.5, to find the time, which is the period it takes for the pendulum to make one complete oscillation, we multiply by 4. So why multiplying by 4? So we have this one, then going back, which is the third, then fourth. So we have 4 movements, equal movements. So we multiply that, we end up with 2.0 seconds. So that's the period, which is A. We move to question 3. The figure below shows a graph of how the speed of 2 athletes changed with time. Which of the following is true about the athletes at time t? So what is important here is at time t. So it's at a specific time. Remember, it's important to understand the question clearly. So athlete 2 is slowing down, which is athlete 2 started slowing down here. Then by that time, the athlete 2 is almost having the same or constant speed. So A is incorrect. Athlete 1 has 0 acceleration. So remember, acceleration is equal to a change in velocity over time. So the rate of change in velocity per time. So what you notice here is the speed is changing, so velocity is not a constant. So acceleration cannot be 0 if velocity is constant. So what is constant here is the rate of change of velocity per time, which is acceleration. So acceleration is constant, so B is incorrect. C, athlete 1 is overtaking athlete 2 at t. No, we can't tell because we are not given the distance traveled. D, both athletes are moving at the same speed. So D is the best answer because these two speed graphs are crossing each other. So that's how that's the case. We move to question 4. What is the weight of 75,000 grams man on the moon where gravitational field strength is 1/6 of the 10 Newton per kg? So weight is given by mass in kg multiplied by gravity. So mass, we convert it to kg, so 75,000 grams. So the first thing is how many grams and 1 kg? They are 1,000. So hence we divide by 1,000, we end up with 75 kg. Then remember, we are told that gravitational a field on the moon is 1/6 of the 10. So which is basically what it means is gravity will just be 10 on Earth multiplied by 1 6, which is basically, we simplify that, we end up with basically 3 into 6, or 2 into 6 is 3, then 2 into 10 is a 5, so we end up with 5 over 3 as our gravity. So we substitute, we have 75 kg multiplied by basically 5 over 3 kg per newton. Remember, the kgs will cancel. If you have kg here, then here we have newton per kg. So what you notice here is the kg cancels each other. Then we have 3 into 75 is a 15. 3 into 3 is a 1. So what we have is 15 times 5, we end up with 125 newtons as the weight of this man on the moon, which is basically B. Let us move to question A5. Why is a bus carrying luggage on the upper carrier more unstable than the one carrying the luggage on the lower carrier? So what we need to know is basically, the higher the center of mass, the more unstable it is. Okay? Then the lower the center of mass, the more stable it is, because the top over may is unlikely to happen. So A, the center of gravity, is raised. So in this case, A is the correct answer. Number 6, a ball of mass 0.5 kg is raised from the height of 1 meter and falls towards floor. Which law in the table below shows the potential energy and kinetic energy of the ball when it is at a height of 0.25 meters from the floor? So potential energy, gravitational potential energy, is given by mass times gravity times height. Now, as the ball is falling from the top to the bottom, just before it reaches the ground, all the potential energy is converted to kinetic energy. When it's halfway, half of it will be kinetic energy and half of each potential energy. So the first thing, let us find potential energy. So the mass is 0.5 kg multiplied by gravity, which is 10 newton, then multiplied by height, which is 1 meter. Then we end up with 5 joules. So 5 joules is basically the potential energy at this point. Now, what it means is basically the moment the ball drops basically by 0.75 meter, for it to be 0.25 meters down, then it means about 75% of potential energy would have been converted to kinetic energy. So for us, we need to know how much potential energy would have remained. So what we notice here is out of this, how much is kinetic energy. So just say 5 multiplied by basically 0.75, you end up with basically 3.75. Alternatively, what you can do at this point, you can find potential energy, which will be remaining, which will be just basically 0.5 multiplied by 10 multiplied by what's the height now, 0.25. So if you multiply that, you end up with basically a 1.25 as the potential energy remaining. So potential energy is 1.25, then the other one out of the 5 would have been converted, so it will just be basically now 5 minus 1.25, which will give you about 3.75, the same way we found here. So what you notice here, C is the best answer. We move to question 7. So question 7 reads, an elevator carries 10 people of average mass 70 kg each to a height of 5 meters in 2 minutes. What is the power generated by the elevator? So what is power? So power is given by work done divided by time. So we need to find work done. So work done is given by force multiplied by distance moved, or the height moved. So we have 10 people, average mass of 70 kg each. They are carried to the height of 5 meters in 2 minutes. So let us find them. So force is given by, since the height, now force will be given by mass times gravity times height. So we have 10 people whose combined weight, so what's the combined weight, will be basically 10 multiplied by 70 kg. So this is the mass, then multiplied by gravity, which is 10 kg per newton, then multiplied by the height, which is 5 meters. Then we have basically 7,000 multiplied by 5, we end up with 3,500 joules as the work done. So now, having found this to be the work done, for us to find power, then we just substitute here, which is basically 3,500 we divide by let me use a different color, by time in minutes. So time in minutes is basically 2 times 60, because time is supposed to be in seconds. So you have 2 times 60 seconds, so you end up with 3,500 divided by 120. So that and that cancels, so you have basically 12 into 350. So if you use a calculator, you discover that basically the best answer is A. You end up with basically 29.1667, which is just to 2 decimal places 29.17. Let's look at question 8. The figure below is a diagram showing how a pair of scissors is used to cut a piece of cloth. Which letters below collectively identify parts X, Y, and Z? So basically we need to identify where the pivot, so pivot is much more easier to identify, is where this rotation is happening. So it's Y, so the pivot is basically Y, so A, B out, so remain with C and D. So where are we applying force? Where we are applying force is basically the effort, which is Z, where the hands enter, which is this. So Z is basically the effort. So we know that. Then where work is being done is X. Well, this is where the load is happening. So D is the best answer. Let us look at question 9. So question 9 reads, the diagram below shows the variation of temperature with time as a solid substance was heated. Which of the following statement is true about the graph above in the region? So we can just know that basically at this point, so remember the temperature is being what? Increased. So temperature is increasing, and this is starting from a solid. So the first one is, this is, we know it's a solid. Then the solid would melt into a mixture. So as it's melting, we have solid and liquid. Then at this point, only liquid remains. Then at this point, we are going to have a mixture of a liquid and a gas. Then at this point is only gas completely process is done. So if you look at the options, QR, so QR is, we have condensation was taking place. So it's incorrect. Remember, condensation is basically you are not taking place there, because basically that's melting from solid to liquid. That's QR. Then ST. So ST is basically, you are saying the substance was melting. So the substance is not melting at B. Basically what is happening there, we have liquid and gas, so it's almost evaporation is starting to take place. RS, the substance was in liquid state, RS, which is collect. So C is basically collect. Alright, then TU is gas, not solid, so D is in collect. Number 10, what happens to the volume of a fixed mass of gas when it is heated at a constant pressure? The volume of gas. So for us to answer this question, we can look at Charles' law, which states that volume is directly proportional to the temperature at a fixed mass and constant pressure. So what is happening in this case? So we are heating at the gas at a constant pressure. So temperature is increasing. So what is happening to the volume? Charles' law tells us that the higher the temperature, what happens? The volume should increase because they are directly proportional to each other. So what will happen is basically B, it will increase. Is a correct answer. All others are incorrect. Number 11, the figure below is a diagram of a water wave that shows a small cork Z moving up and down through one complete oscillation every 4 seconds. What is the speed of the wave? So we know that velocity is given by wavelength multiplied by frequency. So every 4 seconds, we are making one complete oscillation. Remember frequency? So the frequency is basically the time taken for basically to complete one oscillation. So what we are getting here is one complete oscillation is done every 4 seconds. So the period for one oscillation is 1 second. So we know that the relationship between period and frequency is basically inverse. So to find frequency is basically just 1 over period. So the period is basically 4 seconds. So we have 1 divided by 4 seconds. Then we have basically 0.25 seconds as the frequency. Okay. Then basically then we know that from here to here is the wavelength, so which is 3 millimeter. So we have basically 3 multiplied by 0.25. This will give us basically when you multiply these two, you're going to end up with 0.75 meters per second as basically the speed of the wave, which is basically B. We move to question 12. So question 12 reads, the diagram below shows a ray of light incident on the edge of a piece of glass. If the angle of incidence I is greater than the critical angle, okay, the angle of incidence I is greater than the critical angle, which numbered ray shows the direction of the light after it leaves the edge of the glass. So what we know is basically we have incident, this one, and this incident is angle is greater than the critical angle. So if it's greater than the critical angle, remember the critical angle is just the angle enough for which the reflected ray will be 90 degrees to the normal. Okay, so basically then we have this is the surface, so it's hitting this surface. So if this critical angle is incident angle is equal to critical angle, it will just be this. So it will be exactly in this line, the normal line. But because the incident ray is greater than the critical angle, what happens is the light will do what? The light will be deflected backward. So it, instead of, because if it's inside here, there will be a bending towards the normal. But if this is greater than, the light will bounce back. So basically, option 4 is the best answer. It will experience refraction if I is greater than the critical angle. Remember, if I is greater than, incident is equal to critical angle, the ray will be this will be 90 degrees. If it comes here, it goes back, bounce back. If it's lower than, it's deflected. So D is the best answer. We'll move to question number 13. So number 13, a ray of light passes through a semi-circular glass block as shown below. What is the refractive index of the air? Thus, so refractive index is given by sine incident. Okay, so this angle of incident, let us call it the normal I. So I, then over sine reflected angle R. So incident angle is the angle between the incident ray and the normal. So in this case, is a sine 60 over, we need to find this angle. So if this is 90, remember you measure reflected ray relative to a normal. So if this is 90, so to find a reflected angle, it will be basically 90 minus 63, which will give us basically 27. So we have sine 27 as our reflected ray. Then after that, basically you use your calculator, you find that this will be 1.9076, which is approximately 1.91 as our answer, which is D. Number 14, a person sees a flash of lightning and hears the thunder 4.8 seconds later. If the speed of sound in air is 330 meters per second, how far was the lightning from the person? So basically, it's just the one distance. You see from there, then it comes. So you know that speed is equal to distance over time. So this is not like an echo. The echo is it leaves, go, and comes back. This one, you are seeing it from there and it comes just one direction. So we are given time in seconds. Then what you are looking for is basically the distance. How far is it? So we have 330 is equal to distance over 4.8, which basically will just be cross multiply. So distance is equal to basically 330 multiplied by 4.8 seconds. So once we multiply that, so basically what we are going to end up with is basically 330 multiplied by 4.8. So we are going to end up with 1,584 meters, which is C. 1,584 meters as in the distance. So C is the best answer. We move to question 15. Which of the following is a property of a magnet? So one of these is a property of a magnet. So attracts all metals brought near it. So the magnet only attracts ferromagnetic materials. Okay, so these are materials. So there are certain metals that are not attracted to magnet. They're because they are not ferromagnetic. So it's not all metals, so A is incorrect. B, repels all magnets brought near to. So only D to only repel like poles, north to north, south it will attract. So B is incorrect. C, when fluid is suspended, it lies in the east-west direction. So I think this is incorrect. So when fluid is suspended, it lies in the north-south direction, which is D. D is basically the correct answer on question 15. So in case you don't know what ferromagnetic materials are, these are basically the iron, cobalt, nickel, and some alloys. Let us look at question 15. Which of the following will increase the resistance of a material wire in a circuit? Which of the following will increase the resistance of a metal wire in a circuit? So M, the longer size of wire, temperature lower. So basically, if you look at the factors, you need to see the factors that opposes the flow of current, which is resistance. Basically, the 4 key factors are basically you know that longer wires increases resistance. So because the distance, the longer the distance, the more resistance. So longer wire is true. Thinner also basically is also basically, so if the cross section is smaller, then the distance will be higher, but if it's higher, then if it's the cross section area is big, then the distance will be lower. So in this case, increase, so longer and thinner is true, shorter no, so C is out. In terms of temperature, so basically the higher the temperature, the higher will be resistance. So there is inverse proportion relationship between the temperature and the resistance. So if the temperature is high, the resistance will be high. If the temperature is a lower, resistance will be lower. So the higher the temperature, the higher the resistance. So temperature must be higher, and the wire need to be basically thinner. So cross section area should be smaller. So basically you notice that B is the correct answer on 16. We look at question 17. The diagram below shows 2 resistors in a series connected to a 3-volt battery. The ammeter has a negligible resistance. What is the resistance of R? So we need to understand basically the circuit. So this circuit is basically a series circuit. So basically we are told that we need to find the resistor at R. Okay, so we are told that this is the voltage. Then if you know the voltage, basically we can find resistor by using resistor is equal to voltage over current. Remember, voltage is equal to current multiplied by resistor. So to find resistor, we just divide both sides by R or by I to find resistor. So we know what the voltage is, 3 volts. Then we know what the current is. So we can find the total resistor is basically 3 divided by 0.5, which gives us basically 6. So 6 ohms is the total resistor in this circuit. But we know that one is 1 ohm, and this is a series circuit. So for a series circuit, the total resistor is just the addition. Okay, so we know this is 6 is equal to, we know this is 1. Then to find R2, so is 6 minus 1. Then R2, so remember when this one crosses the equal sign, so R2 is basically equal to 5 ohms. So 5 ohms is basically resistor, which is basically C. Number 18, the graph below shows a trace on the screen of an oscilloscope when connected to a transformer. If the Y controls is set to 5 volts per centimeter, what is the value of the peak volt. So the peak volt is basically equivalent to the amplitude. So it's basically this distance, or this distance. So this is the lower, but this is the peak, the top one. So we know that for every centimeter we have 5 volts, and at this point this is the halfway. So each one is 2 centimeters. So if 1 centimeter is equal to 5 volts, as you can see from here, we are given the halfway, then this is the 2 centimeter, then 2 centimeter is equal to what? X. So you see, we cross multiply x centimeter, which is x1 centimeter, is equal to 2 centimeter multiplied by 5 volts. So we divide by centimeter, we divide by centimeter. So 2 times 5 volts, where x is equal to 10 volts. So 10 volts is basically the best answer, which is C. Which one of the following travels in the straight line across a magnetic field? So across a magnetic field, what is not affected? So remember, the proton is a positive charge, will be deflected because there will be an induced current. Then also beta particle will. Also alpha particle will. So alpha particle will always basically heavy, and it will be deflected slightly in one direction. Then basically it's only the gamma ray, because these are electromagnetic waves with no charge. So gamma ray, they have no charge, so hence they will not experience any magnetic force in they travel through a magnetic field. So B is the best answer. Remember, alpha particles, they are rays, but then they'll be deflected, and they are heavy and positively charged particles. Then beta rays are basically, they are light and negatively charged. Electrons they are also deflected strongly in an opposite direction. So you need to know this. Then proton is of course a charge, which is a positive charge. It will also be deflected because of the current and magnetic field. Number 20, the radioactive element thorium 234 930 with half-life of 24 days decay by emitting a beta particle. How long would it take for 1 gram of thorium to decay to 1/8 of the mass? So remember, there is always a question on half-life, and this is a giveaway question, so you need just to know the formula. So we know half-life, the material at a particular time is equal to the initial material, then 1/2 multiplied by time that has passes over half-life. So in this case, this is the initial 1 gram, then what remains is that. So what remains is 1/8 is equal to the initial, which is 1 gram, then multiplied by 1/2 multiplied by t. What's the t? T is the half-life is 24 days. Then we are looking for the time. Okay, how long, which is the time. So we are looking for t over what's the half-life, 24. Then 1 times anything is that thing, so we end up with 1/2 to the power t over 24. Then 1/8 can be written as 1 times 1/2 times half times half, which is 2 times 2. 1 times 1 is 1 times 1 is 1. 2 times 2 is 4 times 2 is 8. So it can be written as 1/2 to the power 3. So this is the same. So now, by the law of indices, if the bases are the same, it means the powers are the same. So what this tells us is basically 3 equals to t over 24. Then you cross multiply, so you have 3 multiplied by 24 equals to t. So 3 multiplied by 4 is 12. I mean the 1 3 times, or carry 1. 3 times 2 is 6 plus 1, which is 7. So basically t is equal to 72. So basically it's 72 days, because the half-life is 24. So basically this is how you get the 20 marks from this section, which makes it easier for you to move towards getting that distinction. So join me as I look at section B.